So hi everyone. Thanks for joining today's Meet the Developer Digital Innovation webinar. I'm Sarah Wells, the Business Development Manager for AREG, just for those who don't know me. I'm extremely excited to be facilitating today's event, and it's a really important event that is about showcasing the digital advancements that are driving the renewable energy projects, fostering the growth of the energy transition, particularly in the northeast of Scotland. For anyone that hasn't sort of seen the AREG Digital Innovation notices before, this project is part of, or this event is part of AREG's Digital Innovation Project, which is funded by the UK Shared Prosperity Fund and in partnership with Aberdeen City Council. As a background to the project, for those not familiar, the project is entitled Enhancing Offshore Wind Renewables Through Digital Innovation, and it aims to assist digital tech companies transitioning into the offshore wind sector through offering leadership support, networking opportunities, and delivering tailored expert advice from industry specialists, just like what you will see today. If anyone has any questions about the project or any of the events that we've held in the past or aiming to hold in the future, please get in contact and myself or the team would be happy to help. So today's event will be split into two sort of mini sessions. So in the first session, you'll hear from Richard Aukland, who's the Director of Research at Offshore, and Steve Aitken, the Founder and Director of Intelligent Plant. There will be a brief 10-minute Q&A session after the first session of today's speakers, and then we'll move on to session 2, where we will hear from Adam Robertson, the Business Development Manager for Fugro, and Fabien Germond, who is the Business Developer at Exail. So without sort of any further ado, I will pass on to today's first speaker. We will have Steve Aitken speaking first. Steve founded Intelligent Plant in 2006, and they have been developing software solutions and apps that help industries optimize operations, reduce waste, and improve decision making. So today, Steve will be speaking on one of Intelligent Plant's projects that showcases the feasibility of explainable AI to support decision making as applied to hydrogen generation. So Steve, I will stop sharing my screen if you're able to share yours, and I will pass over to you just now.
Hey, are we all good?
Yeah, I can see perfectly.
Thanks very much. So thanks very much for the intro, really good. And thanks for allowing us to be part of this event. My name is Steve Aitken. I thought I'd start this with a wee overview of the sort of stuff I do and who I am. So yeah, I set up Intelligent Plant in about 2005, 2006. So it's been going for a fair wee while now. And yeah, we do software historically for oil and gas, and more recently for grid scale renewable type stuff. But I do have a number of hats that I wear. So founder of Intelligent Plant is one of them. I'm also a Royal Society sponsored entrepreneur in residence at the University of Aberdeen. So I'm helping them create startups and nurture the startups that go through the university. And on the board of One Digital, helping to set up digital companies in the local area. So when I speak, I often speak about renewables, and one of the things I show is the data that I have access to, which is actually in my house. Here's a set of 3 inverters and 6 batteries that mean that my house is off the grid most of the time. That means the CO2 generated by electricity in my house is a lot lower than normal, even though I don't have solar. I don't have permission for solar yet. Taking the power from night, it tends to have a lot less CO2 and be a lot more renewables and wind that's generating the power at night. But it gives us a great data set to be able to use and demonstrate the sorts of things we're looking at with connecting to industrial facilities and making a difference through data, knowledge, and understanding. As Intelligent Plant, we do a thing called the Industrial App Store. This is our way of getting people connected so that we can get the data from industrial facilities into tools to analyze that data and help them make a difference. If you do a Google for Industrial App Store, you'll find it there, but I'll not go into that in depth in this presentation. To give you an idea of where I'm going to go in this presentation, there are a few kind of intelligent apps in the Industrial App Store. Valve Signature Tools 1, which can identify failing springs and subsea valves. Wax Intelligence, which will actually identify from a temperature instrument that wax is forming in a pipeline and what temperature that happens at, and alert you when you're blocking that pipeline with wax. So that's really clever, but based on really model-based analytics. And that's saying, I know what temperatures look like, I know how wax forms, I'm looking for kinks. And it's very much driven by a developer saying, I want to detect this sort of thing happening. So that's at the model-based intelligence at the bottom level. The next level is really neural models, where we're looking at things that have neural networks in them and can maybe figure out things that people didn't know. So it's not based on a model, it's based on data. And well intelligence is an example of that, which takes history of valves and valve position along with production rates from an oil facility and can advise on changes to make sure that you keep that facility running, but also get the most out of the ground. What I'm going to be presenting in this presentation is actually a level above neural models. It's not just a neural model of a plant, but it's looking more towards the AI type consciousness that we're all seeking. So we started a project with University of Aberdeen, EMEC, and ourselves, and applied for the title Feasibility of Explainable AI to Support Decision Making as Applied to Hydrogen Generation. We were really lucky in timing and had to do a lot of explanation in this application because this was applied for just prior to a thing called ChatGPT launching. So we had to describe what we were going to do without being able to point at ChatGPT as a thing. As it turned out, we were awarded the funding. I think it was the only AI project that was launched in all energy in that year. And by that time that we were awarded the funding, we could say, you see that ChatGPT thing? Imagine it applied to hydrogen, and it was so much easier to describe. They've really done us a big favor with that. So we have plans to progress this further with additional funding in future, but we've completed this project, which was around the feasibility of applying explainable AI to hydrogen generation. Now, when we did that, we ended up focusing on a certain set of data, which was alarm data. And we focused on that because we were looking at hydrogen and we were looking at the impact of any incident that could happen in a hydrogen facility. When people are applying for planning permission for hydrogen facilities, there's a lot of nervousness around it because actually it can be pretty catastrophic if something goes wrong. And we wanted to try and make sure that we could use the data as best we could to make these facilities as safe as possible. Here's something that we were working on, and in doing it, we were looking for data of hydrogen facilities, and there's not a lot available. So we ended up creating a game, and this is a screenshot of the game showing a set of tanks, 4 tanks, and a source and a sink for hydrogen. And then we were allowing people to try and keep this plant up. So this is a plant with a set of tanks, and up was none of the tanks are over full and none of them are empty. If either of those conditions happened, the game stopped and you lost. And the game was to try and keep that running as long as possible. So we made this game and started capturing data sets of people playing the game, and then ended up creating an agent that would play the game multiple times really fast and then be able to learn from mistakes. We also modified this so that we could remove information from the agent. So often in real facilities, there may be sensors that are broken or sensors that aren't in place. And it's really about saying, how can I figure out the state of this plant with the minimum amount of information possible and give the best advice with that minimum amount of information? So we were doing that by running this game, running it with less sight from the model's perspective, and then training and training and training it. Now, this was really good fun, and some things happened that we really didn't expect when we did this. First of all, everyone actually quite enjoyed playing the game. We didn't expect that, but people in the office were wanting to play this to see how long they could go for. But secondly, when we ran the model, initially it was only able to run for a few cycles. So a cycle would be we're making some changes and some things are happening. It's effectively a set of time. And it was only going maybe 10 sections of time forwards and it was failing. But the guys showed us a graph and they said, look at this. It's learning really well. And they showed a graph of the number of cycles and number of moves that the model could make going up and up and up to the point that it could almost run forever. And we said, that's great. Can we get like logs out of this to see all the actions it's making so we can figure out what it's doing and understand how it's working, because we don't actually know what it's doing. And when we got those logs, we put them into a tool we've got called Seer. And Seer showed a graph of what was happening in terms of when this goes high in this tank, this valve was opened, this happened, and this is what the model's doing. And when we looked at this graph, we said, this doesn't make any sense because there's no real causality here. It's not like it's going, this tank's gone full, so I'll open this valve. It just appears to randomly be doing things. And then we looked a little bit deeper, and it turned out that the model had figured out a way around the game and was exploiting a bug in the game, and was actually moving things that were broken and able to do things that you wouldn't be able to do in the real world. And this created a really interesting problem, not one that we would find the real facility in the same way, but possibly in a different way, in that it was doing something we didn't intend it to do. But it was getting the outcome that we wanted it to come with, which was it was able to run for the maximum amount of time, because effectively that was the aim we gave it. So this meant that most of the project was spent trying to figure out the right way to create the right metric that could measure that this thing is doing something good. And we were still doing that at the end of the project and still tweaking and tweaking and tweaking the way that we measured success of the model. And I think this is common to lots of AI challenges. In doing this, we also did some more things. So we took a look at how we could help describe the likes of that diagram. So that diagram beforehand is taking a look at events that have happened and what tends to lead to one thing to another. The application called Seer. The feedback we got on this is that that's great, but it seems like there's a lot of skill involved in order to understand what these diagrams mean and interpret them. So part of the project, we used large language models to describe these. And I'd say we had initial success. It's not finished, but we certainly managed to get large language models to understand these and begin to describe them. There's more work to do here in terms of pulling in more engineering context so that they are describing them in the terms that an engineer would understand, or whoever it is that's talking to them, talking to the model in their language, because it could be someone who's very experienced in one thing and not so experienced in another. So this was a really interesting piece of research we did in the project, which I think has some profound outcomes in terms of when we're creating visualizations that show data. If we can show those to a machine, we can come out with a very succinct understanding of the problem, and perhaps never really need to see the visualization itself. So that was one of the things that came out of that project. Another thing that was kicked off by this project was us running models in the office. So this is what used to be a mining rig for cryptocurrency that we had in the office, and is now a machine learning rig. So this has a set of GPUs on it that are actually running a large language model, and one that we can integrate with things in the office and all ask questions, but use very sensitive data that we have access to without putting that to the cloud, which is something that a lot of companies want to be able to do. It also meant we ended up upgrading our main server. So this server runs everything for the office and now has 4 GPUs, 4 Tesla T4s in it, and almost a terabyte of RAM. This was quite an upgrade to the server and meant that it was able to handle quite a lot of requests. It's kind of interesting because when you look at this, you would think that this would be cost prohibitive in terms of buying GPUs, putting them in a server and hosting them yourself. But we compared this. So in cost, this was about £2,000–3,000 to upgrade the server with these things. That's roughly what it costs per month to get access to something similar in the cloud. So after 2 months of using this, we're already winning in terms of cost, which is quite surprising and shows you how much you can save by doing things yourself if you're needing to do that, but also how much more secure you are with information, because in this case, that information hasn't left the office, it's still in the office. Now, when we're giving this access to sensitive data, what we did was we pulled in our documents from the server. So all previous jobs, all proposals, engineering documents, and all of the information that we own that perhaps we wouldn't be able to share with someone else. When we did that, we used a thing called a RAG. This is a database that actually understands concepts. And when I say concepts, think about a search engine with a difference. And this is an example to try and get that difference across. If you type into a search engine pipeline, you'll find two things. You'll find things about oil and gas pipelines, and you'll also find things about software development pipelines. Those two look exactly the same to a search engine. And unless you give more words that happen to be in one context or the other, you're not being specific, and you can't get the difference out. In RAG, with this database, it understands the difference between those words based on the context. So this database has gone through all of our documents and understood the context of every word in those documents, such that if we ask a question of the equivalent of ChatGPT, this can find information in all of the documents we've got and bring that to help answer the question. So that can be engineering knowledge that actually helps describe the plant. So if you imagine the diagram with the hydrogen facility and things going wrong, we can pull in all the engineering documents and use that as knowledge to say, it looks like a pump, and it's the big pump in the corner that's having an issue. And by the way, that's the one that Bob spoke about yesterday. So we can pull all that context in to say what things are. This is really cool and has led to doing a number of things, one of which I really liked, which is I struggle with our ISO standards. Our ISO 9001 and 27001 standards have a number of procedures that you have to do in different cases, but knowing you have to do them at any point in time is quite challenging. You need to really remember all of those standards to be able to go, I need to do this. Well, we pulled those standards through this database, and then we can ask questions and say, in my case, I need to create a new machine. What do I need to do? And it would say, you need to add it to this Excel sheet. You need to get approval from this person. You need to create a name like this, and you need to contact this guy. And that really helps to make sure that people are actually following standards by giving them it back in their language at the time they need it, as opposed to saying, go memorize this, where it's very hard to if you're not doing something at the time. So here's another example where we put in all the user guides from our software. So this is one of the models we're using here, which is Llama 3.1 Storm, and we gave it all of our user guides and said, how do we change a trend to our PCP? Without that context, it would not be obvious why I was asking. But this has gone, looked at those manuals and understood that we're asking about a certain view in Trend, the app that we build, and has told us exactly how to do that in Trend. And you can see that it's referred to the user guides here. So it's saying it's found two things in the user guides, it's pulled them out and then giving us an instruction based on the request we put to it. So this is far better when you think about user guides for tools, because really what happens is you go, how do I do this? You don't tend to read the manual and memorize it. You tend to get to a point that you go, wait a minute, I don't know what I'm doing. And at that point, using the user guides as a basis, you can actually start answering questions. So this creates a very different way to interface with user guides. In this case, we were looking at how we could integrate this with engineering data and help advise people. So in this case, we're looking at it, we've got engineering documents in place, and we're saying what things could cause a sudden drop in the inlet temperature of a reciprocating compressor. And you can see it saying perhaps it's the ambient temperature. There could be an increase in cooling water rate. There could be a blockage removal, change in gas position, composition. These things are all actually really good and roughly right. And that makes a really interesting method of diagnosis, because in this case, when we've got an issue with a plant, be it a hydrogen plant, an oil and gas plant, a renewable energy plant, we can actually pull in and say what could cause this, and then say, oh, but we've also got this other issue, what could cause that, and what could cause both of them, and start reasoning on that to find the most likely causes of problems so that we take less time to diagnose them. And this, I think, is a really interesting area that we can apply When it comes to the engineering data we look at in the Industrial App Store, so that we can say very quickly, it looks most likely that we have a blockage on the inlet and we're actually decompressing the fluid and that's causing it to be cooler, or it could be most likely that there's a sudden change in ambient temperature, for instance. So this would help in a lot of ways to be able to say, this looks like the real issue, and to be able to prioritize that so that we can then understand what we need to do. Now, the next things here are really, really blue sky, but I think we're a lot of fun. So here we've got an agent that is connected to a real server, and we're able to ask it to do things. So here we said install Python, and away it's gone install Python. And it said, yep, looks like that's happened successfully. Next, we're gonna ask it another thing. I'll just wait for that time. So I'm saying reboot the server. And you see in the background, there's the server, that's it off reboot. So this has got full control of that server, and it's able to do whatever you want with it. One of the most interesting ones, I asked this, where are you? And it sent a command to the server, which went to the internet, came back, and told me where my house was. So this was pretty cool, and able to actually perform very strange tasks by just sending commands to a server and knowing just how to do that. And it's the same sort of model that we had before. So if you look at where that's going, you've got the sort of neural network that's able to understand or able to predict a process. We've then got a model above it that can understand words and what they mean and where they are in documents. You've got an agent which can use that to do something. Then where does that end up? Well, the next stage that we looked at was, well, what are the parts of consciousness, and how can we get this to the point that perhaps it would set its own goals and try and run with them and go and do things. In that space, we then looked at how we would put that together, and it created a number of agents. We used ChatGPT in this case to create code, and then ran that code with the models locally, and had a number of them running doing different things. What was really interesting, the point with daydreaming there is, what always seemed to be missing was something that would inspire it to do something different. It was always drilling down, and if you gave it a task, it would get more and more specific, but never more general. So we reckon that something that's missing is the ability to daydream and just think about things randomly and understand them and move forward with that. Something that helped me is when people ask me for bios for conferences, I never know what to say. This is Copilot with Bing, and I never use Bing as a search engine, but Copilot with Bing is amazing because it's actually pulling all the results and then understanding them and describing it. In this case, I asked it to write a bio for me, and I thought it was pretty good, though I'd never used those words to describe myself. So if you ever get the chance, try it on yourself. It's really good fun. The last thing, we actually set this up so that we could run it on a laptop. So we've got the big models that are running on the server and that rig, but it's actually possible to run these things on a very modest laptop at a pace that's pretty usable. And that means you can use this in a lot of contexts. It might not be obvious. So you could actually have this when you're on a plane without an internet connection and still use it. Or you can use this on a hydrogen facility that doesn't have access to any specialized hardware and be able to still do that level of reasoning and understanding and that level of giving understanding to people. So in this case, it took about 30 seconds to give a response about that long. And you can imagine using this and doing things in the background that then actually we're able to use this to do things that might take a while, but still be useful because it's doing it in the background and then creating an alert for someone and giving them advice on what to do. So that's everything I wanted to speak about today. I hope you enjoyed it. My name's Steve Aitken. If you want to connect to me on LinkedIn or connect to the company on LinkedIn, you can scan these with your phone off the screen. But hopefully you've enjoyed that. Thanks very much.
Thanks for that, Richard. Steve, sorry, swapped about the speakers last minute. No, thank you for your fantastic presentation. It's really interesting to see the integration of AI, not only into sort of day-to-day life nowadays, but also into the sectors in the renewable industry. So I'll now pass over to our second speaker of today, which is Richard Aukland. So he is the Director of Research for Forsey Offshore. He has years of experience in design and development in the offshore wind industry. And today Richard's going to give a bit of a background to the implementation of AI to the global offshore wind market, and Forsey Offshore's experiences in building AI tools to extract knowledge from the noise, with a particular focus on ports and harbours for offshore wind. So without further ado, Richard, the floor is yours.
Thank you, Sarah. Can you hear me fine and see my screen?
Yeah, I can hear and see everything fine.
Great. Yeah, thank you, Steve. Very interesting talk, and I saw a lot of overlap with our experiences in what you were saying. So what I'm going to talk today about is our experiences in using AI, particularly LLMs, large language models, to build a ports knowledge base. I work for TGS Forsey Offshore. Some of you may know us as providing offshore wind market intelligence. We have a database with every single offshore wind farm in the world in it, full supply chains, project designs, project timescales, etc. Very useful for strategic market intelligence. We keep on top of all vessel movements, vessel activity. We have GIS maps, etc. And one thing people have said to us a lot is they want to get on top of ports and understand the plans going forward. It's a sort of request we get quite regularly, but there's such a vast amount of information on ports. That's something we tried a few years back, but it was difficult to come up with anything particularly useful. Given the sort of large volumes of information. And with the recent technological advances of large language models like GPT, we decided it was time to try again and to see that if we could leverage that technology to help create answers to the sort of problems we get. So here's the basic problem with ports. So understanding the current and future port capabilities is critical for bottom fixed and floating wind. And there's no real extensive and maintained databases available. And there's large volumes of information, as I'm sure you're aware, and it's quite complex information, and it's typically unstructured information. There's lots of different types of ports. We have manufacturing ports where components such as monopiles, turbines, floating structures could be made. And then we have the installation, assembly, staging, stroke marshalling port. Choose your favorite phrase. Seem to be quite a lot of overlaps between these, which is essentially where components are brought together and they are staged for installation and then taken out from the vessel to the wind farm. Then we have integration ports, which is unique to floating, where the turbine is integrated onto the floater. Typically, they'll have large areas of wet storage as well. You have O&M ports used during the O&M phase, and then also system integration ports, where you might get sort of hydrogen facilities at the port or grid facilities. So this is, we reviewed various consultancies, projects, and did some industry research and decided this was the sort of information needed for the industry in order to support decision making. So just basic like port location, a general description of it, who owns it, the general purpose of the port, its history, what does it say about its own capabilities, the layout, where all the berths are, terminals, quays, some GIS layouts, how far the projects were, how long it takes to get to the projects, getting a vessel in and out, entrance width, depth, tidal range, access restrictions. So are there any locks, overhead bridges? There's a big problem in the US, for example, turning area. Can you get large vessels in, turn them around? And then the actual physical dimensions of the quay side and marshalling areas, covered facilities, the load bearing capacity, a lot of details essentially. Then from your port, how are you going to get to major transport connections, what the lifting capabilities at the port, the track record of the port. I could go on and on and on. I think you're starting to get the idea here. Also important, environmental sensitivity. So what do you have to be aware of in the port area, and expansion plans for the port. So what are the investment plans going forward? So we wrote this kind of brain dump list of everything that we needed that the industry is looking for, in the hope that we can answer questions like, for example, O&M related questions. Can an SOV access this port 24/7? How long will it take to transit to site? Is the port limited for certain construction vessels? Could this force the use of a barge for installation? What's the quayside length and height? Is there enough storage for my components? What are the fees for using this port? And what's the fee structure per crew member or per vessel? And can I get green power at the port? So we wanted to try and create quite an ambitious project to answer all these questions. And just to give you a bit of a background on how it went, we did a quick proof of concept using OpenAI by uploading loads of documents and asking questions of those documents. And we found that we were having some kind of success. But we needed to dive into more detail. So if in your organization you have a lot of information and a lot of documents, then these learnings that I can show you that we've had now will be applicable for you. Also, they could be a potential solution. So Steve talked about how he used RAG, and that's the solution that we've taken to answer this. So we have large language models such as ChatGPT, but there's two problems with these. Is they don't have access to the latest data. So for example, they're typically over a year old, and they're not trained on and don't have access to all the details that are hidden in the PDFs on the internet. They're only trained on a portion of the internet. So the solution is to use something like ChatGPT, but to then feed it with your own document resource, the relevant documents. So that's what we've got here. And this is a concept known as retrieval augmented generation. So we take something that the user asks and we feed the relevant documents to the LLM and then generate a response. But you can do some quite fancy things with RAG. You can do question and answering over large volumes of unstructured or structured data or multiple sources. So it doesn't just have to be one source. You can access SQL Server databases, things like that. You can build chatbots. And then something that we're prioritizing is structured data extraction. So that is essentially building a database using these large volumes of unstructured data such that we can offer our subscribers downloadable databases of port data compiled from ports all over the world. And then another thing you can do is you can build agents to break down, they can ask complicated queries that link between port data and, for example, third-party APIs looking at wave heights, maybe calculating weather windows on the fly, that sort of stuff. So that's kind of where we're hoping to end up in this sort of complex domain. So this is the solution we took. How did we do it? Or how are we doing it? Because this is very much work in progress. We take data from the internet, deep on the internet, PDF files and various other sources of information. And we add them to a vector store. We've got actually around 20,000 documents that we have analysed. And then the analysts can ask questions to try in relation to data types, and the LLM will follow that prompt. It will retrieve data from the vector store that is relevant to the question that the analyst answers, and then we're extracting a structured response. So basically we say things like, I'm building a database for the port of Aberdeen, and what I want you to do is extract data in this format, in a JSON format. We give it example structure, and we pass it we connect with a database with thousands of documents in, extracts the appropriate information, inserts it into a structured database, and then we're able to show that information to our customers on the map. And so we do this and we iterate through every single port in Europe. We started off with the UK, and we are also able to put a chatbot and connect it to the vector store, such that the same information can be accessed by the chatbot and accessed by subscribers. And this, I have no doubt, despite the problems that we've encountered, this is going to be the future of how people perform market intelligence and market research. One key thing is missing here, of course, and that is off the radar information. You actually can't beat the work of a journalist at the end of the day, but nevertheless, really you can capture a lot of details like this. And here we show an example of an agent that is the blue chappy here, that is integrating between everything and making more intelligent calculations. So I'll give you a quick demo where we're at. So I've actually rerun this in case I got logged out of the website. But basically what we've done here is I've said which UK ports are targeting floating wind, and I get a list back here with 6 ports that have been extracted from the data store, and we've got links to the ports in our database. And then one of the challenges that you have with RAG systems is that well, this is one of the challenges we've had. You tend to get an incomplete response. You don't actually get everything you hope for. So I had to ask it here any more, and I get a list of another half a dozen more ports. And then we can see we've got Aberdeen here. So I clicked on Aberdeen, and we can see the details about Aberdeen extracted from the database on the left. Got fees. These dives down into different categories by vessel size, environmental sensitivities in the area, etc. And so we have all this detailed data across all those categories of information that I showed you at the start, has all been built up, and for every single port in the UK. And we are currently extracting that for Europe as well. And then I sort of back to the chat on the right here. So can you tell me more about Aberdeen's plans? And it gives me a bullet point list of the plans here. And then I ask any specific heavy lift investment plans, which I spelt wrong. And it tells us about the Aberdeen South Harbour, making significant investments in heavy lift capabilities. And what we've done here in the middle is digitize. So this is one part that we had to do manually. We've digitized the UK ports with their sort of berth depths on here, the drafts. Okay, so you can also, I'll try doing a quick one. Actually, do you know what? I think perhaps running out of time on that. So I'll go back to the presentation. But there's another example here where we can ask for a list of electric or hybrid SOVs. We can format it as a table that we can copy and paste out. and then can add in LOA and draft, add in delivery year, can they enter the port of Lowestoft, and actually the LLM was able to understand that Lowestoft is having an upgrade, and when I ran this it said no it can't, but it will be able to as of November. So Lowestoft's just been upgraded, and I hear from Monday the port will be usable, and the LLM was able to detect that. And it can draw charts, so it can give a chart of the transit times from Lowestoft to different ports based on the speed of the SOVs. So work improvements are working, and we want to draw transit distances on the map and allow the user to extract port data into Excel files. So we've had quite a few challenges, and one of the things Steve said was that he spends a lot of time tweaking, going around in circles, I imagine. That's typical of AI projects. There's so many parameters involved that it's hard to get exactly what you want. And then you change everything and you still don't quite get what you want. And that's the sort of iteration that you go on. We've had challenges with the large volumes of information. And as I said before, not getting all the information out. We've had problems with hallucination as well. So on occasion, the LLM will imagine port data, which is obviously not great, imagine investment plans. So we've had to work on ways to filter that out. And we're actually currently restarting our whole approach to have more control over the whole process of the RAG process. So for example, here's an example of one port. We see that one port had over 3,000 documents. And what we did was we actually used an LLM to go through all these documents. And we said to the LLM, look, this is what we're trying to do here. We're trying to build this port system. Can you tell us which of these documents will be useful? Give us a probability. And it highlighted these documents here that we should be using. So we were able to now just add those documents to the vector store to cut out the noise and reduce the chances of hallucination. We add metadata to all the documents now, and that helps with the retrieval queries. And we use the LLM to build the metadata. In fact, we use the LLM to write all the code for the whole system. There's very little human programming in anything that I've showed you here at all. And we use different vector stores for different georegions, and that has helped with the accuracy of the information coming back. So where are we going with this? We're very much prototype at the moment. We're hoping to have it the new system released soon, and we will integrate it with extracting data from our other databases and go on and provide a richer user experience where, as I indicated before, we'll use agents to drag data from different systems and third-party tools and perform more sophisticated analysis. Okay, thank you. I hope that's given you some insights into the process of LLM project development.
That's great. Thanks for that, Richard. It's really interesting to see the kind of similarities and differences between what we use day to day and what can actually be integrated into various different projects, you know, particularly with Steve kind of touching on the more hydrogen side and with you sort of showing the benefits to the offshore wind industry. It's really interesting. So I'll invite Steve back in to kind of share his screen and everything, and we'll just kind of kick off the first Q&A session of today's event. If anyone has any questions, if they can sort of just pop them in the chat, or you can sort of use the little raise your hand button as well. So I'll kind of just kick it off with something I kind of noted down. So, you know, I think, Richard, you kind of spoke about the integration into the offshore wind industry, and Steve, you touched a little bit more on the hydrogen sector. Can you both expand on how digital platforms can improve partnership and collaboration within the supply chain? Steve, I don't know if we can start with you, if you can take on that one.
Sure. I think it's quite interesting when I think about partnerships and how you make them work in the long term. And usually the way to make them work in the long term is to center it around a client and an opportunity. So saying to a client, hey, if we pull these two things together, we can do something for you that we couldn't do otherwise. I think I've seen in the past where you try and create partnerships without a client, it's very easy to get distracted and end up thinking that we are all going to do everything rather than work together to do something. So the thing I would say is make sure you get the client involved as early as possible and start to think about what that partnership is for and what you're really good at that you're pulling together.
That's great. Richard, have you got anything to kind of add on to that?
I suppose in terms of digitalization, one of the, I think supply chain can probably learn quite a lot from where the permitting processes are going with digitalization. So for example, in the EU and the UK with online portals for document sharing and common kind of formats that make finding and understanding information a lot quicker. So I know they're sort of hoping to reduce project consenting times by 50% using that method. So a lot of the sort of understanding each other's capabilities and project problems. I think there's a lot of potential there for more digitization in that aspect.
Fantastic. I think we've got a hand up there. John, I don't know if you can turn on your camera and put on your mic there.
Yeah, thanks to Steve and Richard. They're both inspiring presentations. I'm contractually obliged to say that, but I really mean it. And they were both given in real, what I would call layman's language. So I've got a question for each of you, if I can. Steve, one of the things that you were talking about was how you managed bias. And I immediately thought about unconscious bias in recruitment and all the thousands of CVs that come in and how it might be used to help HR departments make more intelligent decisions about who they need to talk to. So that's a question for you. And Richard, again, we know each other well, but I was fascinated about when you've got this volume of material and stuff, how you manage any of that information within your vector base, which might have copyright or, like photographs and images. So there's two questions.
What a great two questions. In terms of bias, I'm not sure exactly what I said that was related to that. It's a really interesting point, bias, and especially when you're using these systems in a way that you're going to take a decision from it or an opinion from it. Because there's unconscious bias that we have as people, but the unconscious bias in the data, of course, whatever is mostly represented will be more represented. So if there is a bias already, it will amplify that bias. So you're spot on at highlighting it as a thing you need to be aware of.
The area that you covered it in was in the Freudian overview.
Oh, right. Yeah,
So
thanks.
I was actually only listening, but making notes.
Well done. So yeah, I mean, I think what's interesting in this space is if you're aware of that, often if you ask these systems to review if there's bias in something, then they're really quite good at doing it. And so being aware that that's a question to ask, and something I didn't go into was system prompts. So when you get these models, you can give them documents but you can give them a purpose and a reason and a common thing you need to do. So if it was on HR, you'd probably be saying, you are an HR advisor. I want you to be conscious of legal constraints. And you need to be conscious of bias. Please, in your response, start with why the response is not biased and why it is legal, and then go into the response. By doing that, you get it to be consistent. If you say the constraints first in the response, because it has to take that into account as it responds further. These things, they generate a word at a time. So if they do the decision first, then they're blocked into that way of thinking. So I'd say
you're helping to set parameters then.
Yeah, you can set parameters and set the means or the way that a response should look. In the case of that agent, I said to it, your response will be a set of commands. So you said to do something and it would send a set of commands to a server. So you can get it to respond any way you want.
So you will take account of the Equalities Act, for example, in the HR thing. No, really, really fascinating. Thank you. Richard, you've had the warm-up time thinking about
No,
your
I've had
answer.
plenty of time to think of an answer to this one, which is quite a difficult question, I should say, John. So it's quite an interesting question though as well, because like, you know, if you're searching for an image on Google, it shows you the image and it says the image might be copyrighted, but still shows it to you. And then caveats that out. So at the moment, we don't have images documented in our vector store. Okay, so we don't even face that issue with the images. But we do intend to go to what they call the multimodal and have images in there. So we will have to deal with that copyright issue and probably take a similar kind of, well, I don't know the exact route, but maybe it will be similar to the Google route. But the other thing we intend to do as well is we're actually going to link back to all the sources such that everything can be downloaded, the documents. So every like we won't be using anything that is like sort of from behind a paywall or anything like that. Okay, everything is a public document, so we could in theory link back to a web page, or if it's not a public document, then it has been shared with us to be able to be used. So that it's possible to develop like more transparent systems that, like I say, people will be able to access, download it. There'll be accreditation, that sort of thing. But just on that note, though, an interesting side point is that, you know, OpenAI, its models are essentially trained on millions, billions of words with no attribution at all to them of other people's work. And they're creative. When you ask it to make something creative, that is built on the top of other people's work, other people's IP. So that's why it's a very challenging question, because actually it's quite hard to develop stuff using large amounts of information without treading this line very carefully.
On the shoulders of giants. Thank you both for excellent answers. I'm going to have to step away, unfortunately, but I think if there's more to come, and this recording will be available.
Yeah, so it will be available, and we'll also share the slides. So we'll make a note to everyone once they're ready to share.
Thanks very much. Really fascinating presentations, both of you. Thank you.
Thank you, John.
Thanks, John. Does anyone else have any questions at the moment? You can pop them in the chat or use the little raise hand function as well. I was just waiting on others coming in. Steve, I've got a question for you that you've kind of already touched on it, but how do you see, you know, your industrial app store fit directly sort of into the supply chain? Obviously, the topic you touched on was more kind of hydrogen, but is it quite transferable between different sectors and areas, or?
Yeah, so the hydrogen one was definitely a reach out into an industry we've not done much with in the past. In terms of sectors that we are actively in, we are in energy and oil and gas pretty actively. And it is rather interesting because the industrial app store is something that anyone can publish to. So anyone can put capabilities in there that can access data for clients. But some of the things we're doing more recently have been around grid energy on the grid, as opposed to energy at the sort of the oil and gas well source. So we've been doing a bit more of that, and a bit more in manufacturing, in terms of allowing them to see the data from their plants so that they can understand how to manufacture more quickly, more efficiently, and more safely. I do think that it's quite interesting when you think about the AI stuff with the industrial app store and how does that all fit together, because you kind of want to be able to go, I'll have that app, that app, that app, and that app, and can I get AI to just go and have a look at it, because I can't be bothered looking myself. So I can see that as being where we'll get to eventually, but we're on the way.
No, that's good. If anyone has any questions, please just pop them in the chat. Richard, I'll come back to you. Have you seen any kind of setbacks regarding, you know, worry around data sharing? Do you have to be quite careful around the sort of like GDPR with, you know, what data that you have available, or do you have all the access to share it once it's approved type of thing?
So, like I say, we just at the significant majority of the information is generally already in the public domain, and we haven't had any. I don't think we get into the GDPR issue. We're not kind of in that problem area, as far as I'm aware. Anyway. So, but yeah, I mean, it is difficult. I do appreciate that it's challenging to sort of know like this sort of fine line about what is what can be used and what can't.
No, that's good. Well, I think that'll kind of conclude our sort of mini Q&A session just now. I believe, well, Richard kindly joined us whilst he's on holiday, so I believe he does have to shoot off just now. But just a quick thank you again to both speakers. I think Steve will jump on the kind of big Q&A towards the end. But Richard, thanks again for your presentation, and hope you enjoy your holiday.
Thank you, Sarah. Thank you. Thanks, Steve. Any follow-up questions, just let me know. Thank you.
So we'll jump right into kind of session 2. So we've got Adam and Fabien. So I think we'll have Adam speaking first. So Adam's the Business Development Manager for Inspection, Repair and Maintenance at Fugro. He manages a diverse pipeline of business opportunities, and today he's going to showcase a little bit of insight into Fugro's journey towards net zero emissions through remote operations. So Adam, I'll stop sharing my screen so you're able to kind of share yours, and I'll pass the floor over to you.
Thank you, Sarah. Yeah, Richard's away to go and hit the all-inclusive bar on his holiday. Yeah, there's some commitment coming on to a talk during his holiday. It's crazy. Yeah, so good afternoon, everyone. It's my pleasure to be given this opportunity to present to you all on behalf of AREG. Today I'm going to share with you all the good things that Fugro are doing. Fugro are the world's leading geodata specialist, and I'm going to be demonstrating to you how we're leveraging remote operations to drive sustainability and innovation, particularly in the inspection and maintenance robotics sector. So yeah, as Sarah mentioned, I'm Adam Robertson. I'm Business Development Manager in Fugro, and more specifically, I'm within the IRM service line of Fugro, and that's inspection, repair and maintenance. So our journey towards net zero emissions has been guided by the advancements in remote operations, and it's transforming how we both operate in marine and land environments. So yeah, as I mentioned before, Fugro are a global leader in geodata. We support our clients.
Sorry, Adam, we can't see your screen if you're sharing it just now. We're not able to see it.
Is it not? Must have gone away. Is that back on?
Yeah, that's it there.
Oh yeah, weird. Yeah, so we're a global leader in geodata, and we support our clients in reducing their project risks throughout the entire project lifecycle, and whether that's in planning, in construction or in operations. And our expertise spans across diverse environments, including both land and marine. And in simple terms, that we map, we model and we monitor the subsurface, offering key insights that optimize project execution and safety. So we integrate cutting-edge geodata collection with digital modeling and monitoring to generate digital twins of the built and natural environment. This integration helps our clients make informed decisions, it reduces risks, and enhance the safety and longevity of their assets. And by visualizing these projects digitally, we help our clients save time, money, and reduce their environmental impact. The purpose of this session is to explain deeper into what we do in the operations phase of the project lifecycle, where we monitor the health of an offshore asset through remote and uncrewed working. So at Fugro, we believe in creating a safe and livable world by unlocking critical insights from the geodata that we collect. Our core values, we're determined to deliver, where we prepare for tomorrow, we do what's right, and we build trust, guide us in everything that we do. And our focus is on key markets such as energy, infrastructure, and water. And this allows us to contribute both meaningfully to both economic and environmental sustainability. Now, our immensely talented marketing team have managed to fit everything that we do and why we do it into this fantastic graphic. You can see in the top left here, that's our remote operations centre. And in the bottom centre here, you can see our uncrewed surface vessel and our ROVs, which we'll look further into in a few slides. So for remote operations, we've gone from traditional operations where they're heavily reliant on personnel being offshore, and this results in delayed data delivery. They have to wait for that vessel to come back onshore to get the data, and higher emissions. The old or traditional model required significant fuel usage, with up to 7 tons of fuel per day used with one of our ROVSV vessels. So we've moved, or are planning to move to, in the process of moving to, all personnel onshore, resulting in real-time data access and significantly reduced fuel consumption. If we utilise our uncrewed surface vessels, we drop down to just 150 litres of diesel per day, as opposed to the 7 tons of fuel per day. So that's a 95% reduction in our fuel consumption. And this operational shift has made our processes safer, faster, and more sustainable, positioning Fugro as a leader in environmentally friendly innovation. So on our remote operations centres specifically, or I'll call them ROCs from now on, they allow us to operate remotely across the entire asset lifecycle by offering remote survey, remote piloting, remote positioning, and remote inspection all under one roof. These services can be delivered utilising our traditional vessel fleet or through our USVs, our uncrewed surface vessels, to capture the data, which is then sent securely via cloud processing to one of our ROCs, or even back to our client's home or office via secure links. So our remote operations centres are now managed from several key global hubs: Perth, Houston, Aberdeen, and Singapore, to name but a few. These centres enable us to deliver consistent, real-time oversight of projects worldwide, improving efficiency, safety, and all the while reducing our environmental impact of travel. And you can see all the dotted lines connecting pretty much each one, and it allows us to, as one maybe remote operations centre goes to sleep or has a high demand of workload, they can then actually transfer some of the remote operations to another office there. So the benefits of operating remotely for employees, this means improved health and safety, and improved work-life balance, and a follow-the-sun model where our teams in different time zones collaborate seamlessly. For project teams, they benefit from enhanced continuity and support, ensuring a smoother project execution and better decision-making. For Fugro, it's rather straightforward. Remote operations enhance safety, growth, productivity, and sustainability. And for our customers, the benefits are equally transformative. Projects are safer, faster, and more resilient, all the while contributing to their environmental sustainability goals. So what the future looks like. So Fugro have invested and are still currently investing in cutting-edge technologies like our USVs and EROVs, that's electrical remotely operated vehicles, and advanced communication and robotic solutions to further enhance our capabilities. For example, our USVs are now equipped with Starlink, which has improved our connectivity. These tools are shaping the future of asset inspection and maintenance, which reduces the need for manned vessels, crewed vessels, and enables remote real-time data acquisition and analysis. This is a snapshot of some of the personnel you might encounter if you're in one of our ROCs. So this includes surveyors, geophysicists, data processors and ROV pilots. They now work in a fully remote capacity supporting operations globally with precision and expertise. These roles are now open to a far greater and more diverse resource pool with the removal of offshore working. Our staff can now return to their friends and their family and loved ones after their shifts, which improves their work-life balance immensely. Additionally, our resource pool is now open to those who might not have previously been able to work offshore due to medical reasons. Now, this infographic shows you our route to net zero. So like many of our peers, we have ambitions to reach net zero by 2035. And integral to this target is our USV rollout and the conversion of our existing fleet to greener fuels such as methanol. So for example, our Fugro Pioneer vessel in the Netherlands is currently getting retrofitted for methanol conversion. So on to our uncrewed surface vessels, or as I'll refer to now, USVs. Going forward. So our USVs, like the Blue Essence here, are at the forefront of our remote operations, making the future of inspection robotics more autonomous and efficient. Currently within our Europe and Africa region, we have two 12-meter Fugro Blue Essence USVs within our fleet. The Blue Essence are currently the only USV on the market with a deployable ROV currently doing inspection work. This makes it the only USV capable of providing remote offshore inspections. The Blue Essence is equipped with a Fugro Blue Volta EROV, designed and manufactured in-house by Fugro. Now, the near future, what that looks like for Fugro in Europe and Africa is from Q1 in 2025, we'll be adding an 18-meter Fugro Blue Eclipse USV to our fleet. Along with the larger USV comes a larger, more robust EROV, the Fugro Blue AMP. And this is capable of doing far greater subsea and inspection and intervention work. We'll also be adding a Fugro Blue Prism USV, which will be exclusively used for geophysical survey, so no ROV on board that USV. Now, our USVs are not just a mere concept. Our fleet have been delivering exceptional inspection work to our client base for almost 2 years now. But don't just take my word for it. I'll show you now a brief video to demonstrate our USV in action. So those of you who are local to Aberdeen would have maybe recognised a couple of the sections of the video there. So that was at the Aberdeen Bay Wind Farm that you can see as you're kind of coming off the bypass at Balmedie, and you can saw it coming into the Aberdeen Harbour as well. So yeah, as shown in that video, one of our key successes was conducting the world's first offshore wind farm inspection using a fully uncrewed surface vessel and EROV at the Aberdeen Bay Wind Farm on behalf of Vattenfall. So all personnel were onshore and data was streamed live to clients all across Europe, which showcased the efficiency and workability of this approach. So Vattenfall were so impressed by our work at the Aberdeen Bay Wind Farm that they wanted to scale this up at one of their Dutch offshore wind farms. Our work at the HKZ wind farm demonstrated the value of remote inspection technologies, covering 140 wind turbine generators and multiple substation platforms. You can see some of the images taken from that inspection. So the bottom left image, this is a bird's eye view of one of the monopiles. And if you look closely here, you can see the rock dump at the base of the monopile. So you can see the detail that you can get from our USVs. And the bottom right image shows you a still of a cable entry survey. So thank you for listening. Fugro's journey towards net zero emissions is not just about reducing our environmental footprint. It's about transforming the way that we work, from remote operations to cutting edge robotic solutions. Thank you for your time, and I look forward to any questions that you may have.
It's fantastic. Thank you, Adam. It's really amazing to sort of hear how much you can do without, you know, the crew even leaving the shore. It's amazing, and another success story for the Northeast, with it being the first fully remote offshore wind inspection. So that is fantastic. So I'll now pass along to Fabien. So Fabien is the business developer for remote and autonomous survey operation at Exail. He hosts years of experience in offshore survey project management, and today he's going to showcase Exail's development of digital solutions and an overview of Exail's portfolio, from hydrographic and oceanic capabilities to remotely operated vessels and some more as well. So Fabien, the floor is yours to share your screen, and we look forward to your presentation.
Okay, thank you for letting me presenting that. Can you hear me fine?
Yeah, I can hear you. Okay.
Okay.
I can see your screen.
And you can see the screen. Okay. Good evening, everyone. So first, a quick reminder regarding Exail, because it's kind of brand new. It's a joint company with from ECA and XBlue that you might already know. So just a quick overview, but yeah, 2,000 employees and basically focusing on the innovation and producing products for clients from from space down to the deep of the ocean, and really around the photonics in engineering. Just to show about the footprint, many all of our companies are based in France, but a lot of commercial footprints. Quick say, we building innovation from each component that you might have in your different system, or full equipment, actually, from the inertia that you may know, the subsea positioning, quantum as well now, and simulator. And then we move also from, because we've got a shipyard and building so USVs and AUVs, and also some aerials, and now also bringing all of that together, really to bring some complex system such as the mine warfare or the geophysics. So it's to bring all of those equipment inside on board our platform. So what about regarding the hydrographic and oceanographic? What couple of equipment? I will go very quick, as you already know them. Most of the INS from surface and also use in subsea USBL positioning, and also a really precise LBL positioning, and which was used in the past on some offshore wind farms, really to really locate precisely the jackup, and of course the software suite. Also regarding the sonar, some sub-bottoms and some synthetic aperture sonar, and also some multi-beam. So really to have the broader spectrum of equipment to be mounted on our platform or on your vessel. Talking about the USV, the Maritime Autonomy Solution, you may be aware of the DRIX H8. So it was the first launch about several years ago. from now with certain fuel capacity and range, and being able to really implement some sensor. Then we brought from demand to have more autonomy at sea, the DRIX H9. So it's 1 meter longer, H9 for 9 meters. And now it was launched this summer, the DRIX 016, so 16 meters. And basically this one being able really to have all of the geophysical sensors on board, and also some the capacity to launch inspection class ROVs or ROTVs. Yeah. This one can run, really long range and doing some transatlantic works easily. Yeah. Regarding our operation, just a quick just to say that, yeah. So this DRIX Ocean was built up quite quickly in regards to, thanks to all of the feedback and the knowledge that we gathered through the years using the DRIX H8. So those products are for sale, but we also come along with our clients to really do some trials and to first accept it on their field. That's why I can present several projects that we have done. Just to give you an overview about where are the DRIX up to now, and the different projects that we have done with our clients. And so to cover that, you've got the fish stock assessment, quite a high demand. Also the capability, as mentioned, to really track the AUV and the ROV positioning, especially when you are dealing with a deep water survey, and really having and kind of brings the force multipliers. Basically, you've got your mother vessel doing one job, and you've got also your AUVs and the USV following it, and really acting as a positioning system, but also to transfer all of the command. And also, thanks to the sonar system, you also being able to really have an awareness about what is going on the water column, for example, to secure the route of navigation or different obstacle avoidance. Yeah. So all of those DRIX are already owned by our clients, are currently running and hitting a lot of nautical miles. So I'm going to present and focus on what we have done on the offshore wind farms, especially for the maintenance, so the survey of the quay of the interior eye and the monopiles, just to present you how we've been working with EDF on the Fécamp and on all of their sites, and they really we've been really implemented into their remote operating control center. And so now the concept of operation is really flexible, as we do port-to-port operation. As mentioned, that Starlink now open up really broadband communication and stable and really with low latency. So we are really on board. And of course, it has said, and as you can see from its shape, so that's how it came with a CTV. It allows what's really interesting thing is that as it's very, very small compared to standard vessel and very light. I mean, we just weigh 1 ton of plastic. So basically, they allow us to really go close to the pile. So from 10 to 20 meters to really have a good and precise inspection of the monopile, which could have been more tricky, with bigger vessel, of course. And we easier on our side to operate 24 hours, with all of our sensor on board. as it's not really mentioned, but with a full sensor for the awareness from the thermal camera, lidar, radar, and so on. That's sort of quite a really high precision and fine comparison of what is going on really on the cables and on their assets. Also mounted on the Echoes 3.5, and really having thanks to this job, it's easy to bring other sensor and having a good view also about the depth of burial, kind of some detection, kind of to really let the operator really to come and to visit with an ROVs after that. Just to come back, for what is as this platform is really stable, as you can imagine, with this profile and having some roll stabilization on board. Whatever the sea conditions, the platform really remain really stable. And so now the acoustics from the sonar equipment is just revealed completely. And so we've done a couple of comparison and trials to compare and to assess, and we stay within a really high precision over different years. About the H8, you've got about 3 days at sea at 8 knots, of course, and about 7 days for the H9, and about 3,500 nautical miles for the DriX 016. So it's was launched, just to give you a quick view, but some surveys around, not really on the pile by itself, but more on the jack-up side, to see the bottom condition. So which was done way quicker than the usual way. It was mentioned a bit earlier, but with those USVs now, as you can imagine, it's not definitely not the same size, and the saving from the CO2 or from fuel is directly linked. It's huge, definitely huge, and it's mentioned about between 90 to 99%, depending on cases. So this one was really done a comparison in live in England, and of course you've got the man-hour risk exposure. Regarding some geophysical, more and more from the size, we are able to really have the complete ecosystem of the geophysical sensor ecosystem, the multi-beam, the sub-bottom, and now having the capability of launching, that was the final step, kind of, being able to have the side scan sonar at the same time, to run everything all in once. So that's, as you can see, that's an ROTV, remote operating towed vehicle, so it's fully controlled, and in order to keep its immersion or its altitude, it has a positive buoyancy. So basically, it just flies along and behave really nice during turns. And you can add some magnetometer at the back as well, and to carry some UXO application. So at this stage, for the smaller from the smaller USVs, the DriX H8, it's a fixed length and it's just towed behind it. But with the DriX 016 is really to tackle that and being able to recover it and launch it at sea. So it has a real winch on board, and so basically you can run some port-to-port operation without having any assistance vessel. Just a quick view about what we can implement in the gondola. there is enough room to accommodate the single beams, the multi beams, TVL, and all sort of sensor. To give you to highlight what the USVs are now capable of, you really think about you're able to really having your main operational port quite far away from your survey side. And so here it's just to show you that it was 500 kilometers from and to the survey site, which with offshore vessel to come here, to come up to there with all of the mobilization cost. So that was for the scientific purpose with not the same budget. So we were able to carry their survey. We are within about 3 or 4 days. With beautiful seabed feature, and here you can have you have a view of all of the data trapped in the software. So the subatom, the multi-beam, and that's it. There is no side scan with this one. Regarding the fish stock monitoring, and especially it was a need in the US, and it is coming in Europe, being able really to monitor the biomass inside of the offshore wind farms. So it has, the idea is it was done with NOAA, and they selected thanks to the navigation capability and the really silent platform. And so to survey all of the fish and the plankton before the site is occupied, during the construction, and to monitor it year after year. And it was successful with CPIC, so it's a multi-beam, which really have a great understanding or clarity about what is going on in the water column here. About the same, but monitoring, just to highlight some operation, as you can now, the limit, it's not only coastal work that we can do. Actually, as you can see, we are working with one of our clients to really go on at the continental shelf. So here you can see it was done in February in the Gulf of Biscay. Nice condition up there at this time, and 150 nautical miles from shore, and doing back and forth lines to really assess the stocks and also the marine mammals behavior. And it was kind of to present the comparison. If it would have been done with one of their standard vessels, the fuel consumption that we saved thanks to this operation, as you can see, is huge. I mean, you are saving about 95%. And especially, of course, the man-hours exposed at sea, it's huge, and especially during these winter times. But also, it brings also that you can actually, during one mission, activate who is going to do what. Instead of to bring all of the experts all in once for 12 days missions, basically, we had different tasks throughout the day. So basically, each scientific and expert came in and really tune and define their survey for the day, and so on. So they were, it was really optimal doing that way. So now, as you are now aware, the bigger one, the DRIX 016, and to have a really almost full ocean depth acoustic capacity with EM 104 or 304, so you can almost bring everything on board. This one has, of course, a full redundancy, and it's currently under progress. I mean, it will be from Q1 2025. It will be ready to being able to launch the ROVs, the inspection one, from this platform. So we are currently building it, and it will first sea trial will be done early next year. Yeah. Just to as takeaway points, it becomes series. So we've got more and more pushing the limit and the application. Very versatile and open architectures from the multiple payloads, the comms, and also the way that with the ROSBAG as well, how to deal with all of those data collected on board, because you don't have only the scientific data, but also the engine, the behavior of the platforms. So wide range of services that we provide from training, offshore support as well, rock support, maintenance, spares, and so on. We are constantly improving, of course, thanks to the field. If I've got 5 minutes, I want to highlight just one thing that has been released this year, and we have carried some larger survey with it. It's kind of to change. We were used to, the standard is to bring the side scan sonar and to tow it back from the stern. Of course, it has a lot of limitation, and so our view is to integrate the SAMs thanks to the synthetic aperture sonar. So basically, this one is really a motion tolerant, so because it really implements an INS, and you keep the right resolution up to the end of your swath. So you can do really at high speed in motion seas actually, and still getting the right data for EHO order 1 or better resolution, but that you have to really reduce a little bit the speed. So that's something which is now it's capable of. Of course, it has to work from 0 to -5 to about 40 meters. But it's just an image, but what you should get or what you could get with the standard sonar, and when you bring it to the synthetic aperture sonar approach. A couple of cool images. The right resolution up to 300 meters swath at 30 meters depth. So we are flying about 30 meters high, okay, and in a sea state 3. So as you can see, the object that we can discriminate the 40 centimeters on your left or in the middle. So that's bringing a really good advantages in the coastal areas. It's currently under process, but of course, as we are dealing with the synthetic aperture sonar, we are able to extract the interferometric bathymetry out of it. So it will be presented early next year. Just a couple of views about the integration. So it can be also pole mounted, but it's just to show you what we've done on a project. And it's easy to be put on AUVs, of course, because it was made for that, and also on gondolas. Yeah, it's an OM, and we are currently doing a job with David Evans, DA for NOAA in the Gulf of Mexico. And we have carried about 20 days of acquisition, about approximately 2,500 nautical miles up to now, and in a really sea state 3 as an average, but still operating fine at up to sea state 4. Yeah. So it meets the criteria for the EH order 1A, and being able to define or to detect a symmetric object up to 100 meters range. Just to show you what's different impact from the speed. So we are not affected anymore by the speed, and as the vessel, as the Drix is not moving that much, and it's also compensated with the INS on board, of course, brings a beautiful data set at the end. Thanks for your attention. Feel free to contact us if you've got more questions.
Perfect. Thank you, Fabien. I believe it. Are you based in France? Is that correct?
Yeah, it's correct.
Yeah. So we're getting a bit of a global insight here as well. No, it's really great to hear a bit of an overview of Exail's projects and operations. So I'll invite Adam back on if you're able to turn your camera. Perfect. So we'll kick off another sort of short Q&A with yourselves, and then we'll invite Steve back in for anyone who might have questions for the kind of whole panel. We've had a couple into the chat. So Adam, I think this one's for you. How many eROVs do Fugro currently have in operation, and is it difficult to get clients' trust in a remote vessel?
So the first part is easy for my answer because I don't actually know. Well, yeah, we've got we have one per USV at the moment, and then we actually have some that are just deployable off of a regular vessel as well. So the number I could probably go and look out for you, but yeah, I'm not overly sure. The second half was hard to
Is it
convince
difficult
people
to get clients' trust in a remote vessel sort of in comparison?
It's a strange one. So for renewables, so offshore wind, we find it easier. I don't know if it's because the technology of offshore wind is so new, they're more open to newer ways of working. They've not got decades of, well, this is the way that we worked, therefore if it ain't broke, don't fix it. Whereas we've convincing some of the oil and gas operators to go this way has been a bit more tricky. And then it also comes down to the old cliche of no one wants to actually be first. And that's why ORE Catapult helped us a lot with Vattenfall, with the original Aberdeen Bay wind farm work. And Vattenfall have been big proponents of the USV for us for a long time. So having like a major operator like that on our side has helped as well. And it's snowballing. This year compared to last year, we're doing a lot more work. And already into next year, we're looking that we're going to do even more. So it's getting there. We're building up the CV of it.
Oh, that's good. Fabien, I don't know if you've got anything that you can kind of add to that as well. Did you have any difficulty trying to get clients, trusting more in remotely operated vessels in comparison to sort of fully crewed ones?
I fully agree from what you said, and I should add one thing. Now they see that the technology is mature. We have proven, from Fugro and different and on ourselves, and it is mature. It is safe to use. It collects the right data. So now we really show them that we can do the same thing as the usual way. So what is difficult actually is really about the regulation, as it's still unknown, and so that's where they get are we allowed to? So the industry is pushing, but they are not confident with the regulation and the constraints. So it is moving, and actually from last month, I think that all of the Danish, UK, Belgium, Netherlands as well, they come and are working to really have a common practice. So that will really open.
I mean, I think that plays a lot more into what kind of Adam was saying. It's you don't want to be first, but once you know, bigger names started doing it, and when you're hearing from more companies getting more involved, it really probably starts growing the conversation for you guys as well. There's another question being popped in the chat from Samantha. Did you face a pushback from staff when developing remotely operated vessels, or have any worry of job loss to those who were, you know, previously operating on board the vessels? Adam, I don't know if you want to.
Yeah, I can take that one. So yes, we do. We initially faced some pushback, and we still do. Is primarily with you can see the difference in those that have worked in the industry for decades compared to those that were newer in. So the older guard have resisted it more, and we're not at the 100% full remote operations yet. So there are ROV pilots and such like that are on our vessels, and they're still continuing to work the way that they did. But we have brought people on shore. But the job losses we've managed to ease the worries, because we're not getting rid of them. We're just moving it from an offshore environment to an onshore environment. The ROV pilots are still there. They're just in our remote operation center in Bridge of Dawn. So they're still there. But some people, believe it or not, genuinely like going offshore. And I can't relate to that. I've never been offshore. I have no intention of going offshore. But some people genuinely love it, and it's getting into that. But we're doing it phased, and we're still quite a way from having a fully, like, no large vessels and such like, because to put it frankly, the USVs at the moment, and even the next generation that are coming out in the next year, 2, 3, cannot do everything that a large vessel can do. So they're a long way away yet from going fully remote.
And do you see it being a sort of fully remotely operated, you know, industry where you can get the bigger vessels fully remote as well, or do you think that's a very long while away?
It's I can't see the bigger vessels becoming fully remote, but I can see them becoming greener and becoming lightly crewed. Mm-hmm. Because with the larger work class ROVs that are required to do big intervention work and cleaning work on offshore environments, you still require people to do maintenance and all that offshore as it comes in. So you're not going to remove that. Not anytime soon, anyway.
If I can add one thing as well, as you can really want to emphasize the fact that it's for the small assets. Basically, you kind of instead of building a larger vessel which with the highest cost, basically the clients are able to purchase much more USV. So from that, you still need the pilots, you still need the surveyors, you still need some engineer on site. So basically, yeah, it's a force multiplier at this stage, yeah, and it brings more people on board.
Yeah, amazing. If anyone else has any questions, if you can just pop it in the chat or raise your hand. In the meantime, I'll another question for you both, I suppose. And Fabien, if you can kind of take it first. How would you manage a kind of breakdown or connection loss issue? Is this something that has happened and you've had to try and work out how to overcome it? Have you not kind of come across them issues yet?
So communications. It's the main point, and as you can imagine, there is several layers. So we are still always in communication with our rigs, and we know exactly where it is, and we're still getting all of the feedback of its behavior. So first, you've got the full things, long range Wi-Fi, the 4G. You got the Starlink, of course, and the Iridium SBD as well. So yeah. Anywhere we still have all of this redundancy on board.
And Adam, do you have anything to add to that? Is that any issues that Fugro have kind of overcome as well? Or
yeah, so what Fabien has said is everything that we've got within the USV. So there's multiple layers of connectivity that they frequently actually go through. So, I mean, depending on bandwidth, they don't go straight to Starlink. If they're only needing a small level of bandwidth, like for instance, if they're traveling out from the harbour, they use lesser bandwidth as well. And if things were to fail, they've got other things to lean on. And if everything is catastrophic, the USV can actually go into buoy mode and can sit and wait for us to come out and get it as well. And regards to connectivity, actually in our remote operation centers as well, we have various connectivity kind of things to fall back on as well. For instance, our remote operation center has internet connections from both sides of the building. So if, for instance, there was roadworks and it sliced the fiber, it can come out the other, and then as well they can go into 4G as well from there, and as well they've got electrics from both sides as well as a generator. So it's incredibly resilient, and they've not had to. For instance, we've even had the building across the road. Anyone that's familiar with Fugro in Aberdeen, we've got two buildings, and one building houses the rock, and we actually had a power cut on the other side of the building, and the people within the rock had no clue that there was a power cut on the whole, pretty much the whole street, because they had the generator and everything. So we're highly resilient. We've thought of everything. Touch wood.
No, that's fantastic. I've just kind of got one more question. Obviously, when you've got crew on board, you've got to, take account of a lot of different health and safety measures and everything like that. And obviously, you've kind of covered when there's breakdowns, you've got a lot of backups. What sort of innovations or design considerations have you come up with for improving efficiency and sort of, making sure that you can operate during sort of challenging offshore environments, particularly around how close they will be to the sort of wind turbine structures? I mean, for Adam, you obviously said you're not really an offshore guy, but if anyone's kind of been offshore or seen any, wind turbine up close, they are huge. And obviously if there was an issue, that would potentially be quite catastrophic. So what kind of safety implementations do you have for the actual vessels themselves?
That's a good question. You mean USVs or for the big vessels?
Yeah.
USVs.
Yeah. Well, for the ROV that we use has a 500-meter tether, so we don't actually need to get right up close to it anyway. Okay. So, I mean, with the sail effect of the tether, you're looking at about maybe 300 meters it can go. So we can get fairly close to the turbine without causing any damage. It's just the ROV, and the USV is made of aluminium. Ours is anyway. So if it was to hit anything, the only damage it would do is to itself. It wouldn't damage anything else. So it's not really a danger to anything.
No,
and sorry, I should add one more thing, is that the USV is equipped with a guillotine as well. So if, for instance, the tether was to get tangled around anything, whether that's a turbine, offshore oil and gas platform, we can actually sever that, sever the umbilical and let it go. We've not had to do that yet, but we can.
Amazing. Fabien, I don't know if you've got anything to add. I might have just asked a really awkward question for you both there.
No, it's okay. I mean, we just need to really think about the size and the weight of our asset compared to what you used, because it was mentioned it's 1,000 tons of steel usually, which goes really close to the wind turbines. That's where it could get really catastrophic, as you mentioned this world. But on our side, it's way smaller, and it's on our side it's made of plastic. But even in aluminium, it doesn't. We don't go that fast. That fast, and so the damage is it's nothing. Yeah.
Fantastic. So I'll invite Steve to come back on just for a kind of final, any questions for the whole panel, if anyone has any. I don't know if doesn't seem to be any more in the chat, but if anyone does have anything come to mind, please just pop it in. I'll kind of start with a bit of a general one. So what impact do advancements in digital tech have on the scalability and reliability of renewable project developments? Who wants to be the brave one?
There? I think when you look at digital tech, it can be quite useful in justifying future projects. So often when you're putting together a business case, what you need is some real data to be able to say, here's what it's worth, this is what it can save us, this is how much it'll cost. So, you know, putting digital tech in on the project today helps justify the project tomorrow. And that can help justify much larger scale projects, especially if there are challenges with scale. If you find that actually our costs are the same when we're doing, you know, 10 solar panels and 100 solar panels for certain things, then it makes it much more justifiable to do larger projects. So I'd say that that's certainly something that's an impact digital can have on scale in terms of understanding the kind of the cost benefit balance and giving real evidence to that.
Amazing, thanks. I don't know if Adam, you or Fabien have anything to add on to that.
Wait, could you repeat the question one more time? Sorry, just.
What impact do advancements in digital technology have on the scalability and reliability of renewable project development?
Yeah. I mean, for us, it's not really. So yeah, for us, our utopia is them both working together. Because for the USVs, they're going to work even better and be even more scalable once there are more wind farms in place as well. Because then you're not just making one trip and then coming back. You can cover a few offshore wind farms, and then everyone benefits. Everyone shares in the mobilization, and everyone shares in all the data as well. But for us, it's also like demonstrating the intangible benefits. So yeah, it's cleaner and safer, but then it's not necessarily what a lot of we get asked the question, they're like, okay, what's the cost? And it's not as cheap as you think it might be, because there's innovation, and it's trying to demonstrate the intangible benefits, like your health and safety, like how many issues could you have had, and now you're going to have zero with that, and such. So it's demonstrating that, which can quite often be quite difficult to demonstrate.
Yeah, amazing.
Yeah.
Fabien, I don't know
if I can emphasize one thing is also the repeatability of the data that we managed to collect. I mean, from the geophysical side, you have to think about one complete system fully integrated that you bring year after year on the same field, and being able also to have it on different wind farms, I said, and so compared to have mobilizing an opportunity vessel and having all of the errors, you know, from this brand new setup. Of course, you stay kind of within the criteria from your clients, but when you intercompare your data sets, that's not as neat kind of thing.
Fantastic. Well, if no one else has any other questions, I think that more or less wraps up today's sessions. I mean, another huge thank you to all of our amazing speakers. Also Richard, who did have to jump off, but to his dedication for actually joining on whilst on holiday, I'm not sure I would have been as keen. But no, thank you all so much for your insights and everything that you had to add, and to our attendees. Just a quick overview of what else AREG has coming up. At the end of the month, we have a Young Professionals event on career connections and exploring opportunities in the energy industry. So this will be held at One Tech Hub, and it's really just about facilitating the the chance for students, graduates and young professionals to really explore the opportunities that there are all across the sector. For those interested in the kind of digital innovation side of things, we've got a digital innovation and communications event coming up on the 5th of December. It'll be a morning event, so you'll be able to get a breakfast roll in there as well. And it's on revolutionizing communications and renewables with digital tech. We're also going to be hosting our calendar launch and festive Christmas social event at Pataudry on the 19th of December. So we'll launch our calendar and then have a little bit of a chat and social networking space for everyone, and just a little bit of a thank you to our members for the support over the year. For anyone that doesn't know about the Scottish Energy Futures Conference coming up, the call for papers and abstracts is out just now. It's due to close tomorrow, but there may be an extension if anyone cannot get it in on time. So if anyone would like any information on that, then please get in touch. But that is everything for today. Thank you again to all of our amazing speakers and to everyone attending. If anyone does come up with any follow-up questions, I'm sure our speakers wouldn't mind if you just send them over and we can kind of transfer them through. Thanks everyone. I'll stop recording just now and we'll share the slides sort of early next week. But yeah, thanks again.